Welcome to Azure Community Live here in 2021. I'm not sure any of us here would have thought that a year ago that this was going to be the norm for meetups, but here we are. The online meetups have become the norm, and we're happy that we can do our part for it. So this is an online meetup. Obviously, we are here online. It's for the Azure community, and it's made by the Azure community. And I'm your host. I'm Lars Klint, and the idea behind this online meetup is that there are people that can't attend meetups in cities, or well, they used to not be able to attend meetups in cities, and so we created this meetup as a way of making anyone have an access to knowledge, in this case Azure. And I live in rural Australia, and I live in the middle of nowhere, and I cannot attend meetups regularly. It's quite the trek to do that. So this is a way that I can give something back. And speaking of giving back, if you want to be part of the Azure Community Live and submit a session, you can do so on our website or via our Twitter page or on YouTube or wherever you can find us. We will listen. It can be anything Azure, whatever you feel like, as long as it's something that you want to share, and we will be happy to help you share it. So enough about me. I want to get to the speaker for today's event. So I'm in Australia, and Henk Boelman is in Dutchland, the Netherlands, where it's morning. So it's one of those interesting time zone things that I was going to bring a glass of wine, and Henk's having a coffee. So, but there we go. Henk Boelman is a cloud avocado for Microsoft, and he does a lot with artificial intelligence, machine learning, and stuff. And I'm pretty sure today is going to include llamas and machine learning. Is that right, Henk?
Yeah, something that looks like llamas. Absolutely.
We're still not sure that it's llamas, but maybe the machines will learn us, right?
Exactly. Yeah, we'll see what we could find. So, and throughout the talk, if you have got any questions, whatever, put them in the chat, and we'll get to them as well. And it is recorded as well, so you can go back and look at it after the fact. So don't be worried if you miss one step. You can always go back and look at it again. So I don't have anything else to say. Do you, Gid, do you want to say anything before we let
It's great to be back with the second show of the year. Great to do it again as a global event. Me being in the Netherlands, Henk as well, and having Lars on the other side of the world. I think it's just great to be able to share knowledge around the world this way. So let's just get to the content and open stage for Henk. Go ahead.
Cool. Thank you. Thank you very much. Thank you very much for having me in this global meetup. It was fun to be in Australia and in the Netherlands at the same time. So you can all probably see my robot spinning around some tools now on the screen. Awesome. So let's get started. So my name is Henk Boelman, Cloud Advocate at Microsoft based in the Netherlands, and talking a lot about machine learning. So today we are going to talk about machine learning on Azure, and we are going to build a llama, alpaca, cat classifier using Azure Machine Learning because the difference between llamas and alpacas is hard. So, but first, let's dive into what machine learning actually is. So machine learning is the most basic explanation I found was to give your computer the ability to learn without explicitly programming it. So that is good, especially for me, because I'm lazy and I would love that my computer does things without me actually having to type those lines of codes. But in reality, it is a little bit different. So in the old days, I would create an algorithm, basically a function. I would put in some data, do some math, and I would get an answer. But with machine learning, it is switched. First, I have to collect all the answers, then have a lot of data, and the computer will build that algorithm for me using a framework like, for instance, PyTorch or TensorFlow. And that will give you a model, because now the algorithm is called a model. But basically a model is the new function. So when we have that model, we can run new data to it, and it will give us a prediction. So instead of that it gives us an answer, like this is right, it will give us a prediction. I'm like 90% sure that this is a llama. I'm like 50% sure that this is a cat. So it will never say like, this is it. So let's dive into what machine learning on Azure has to offer us. So I like this. It is a little bit older slide, but I think this will make our Azure landscape pretty clear. So we first have sophisticated pre-trained models. And these are pre-trained models by Microsoft to help you build and test out machine learning algorithms and infuse AI in your application without actually doing the AI. So there are APIs that can do out-of-the-box vision for you. There's speech API, language APIs. So just call an API and you will get an answer. So all the machine learning part is handled by Microsoft. But sometimes it is not enough and you want to train these models yourself. And then you need a framework. You have to choose between PyTorch, TensorFlow, Keras, Onyx. The good news is it all runs on Azure. And then we can make your life a little bit easier to have, because we have Azure Databricks to help process your data, Azure Machine Learning, where we're going to dive in a bit later to help you train your models, the complete workflow from all the way from data up to running it in production. And there are virtual machines pre-installed with all the tools and your graphic drivers. So you have out-of-the-box TensorFlow machines where you can train your TensorFlow machines using GPUs. And that's pretty handy because it takes a lot of time to install the right version of Python with the right version of TensorFlow with the right version of your CUDA drivers. Of course, you need CPU, GPUs to train your models. We have enough. And then we can help you deploy your models on-prem. We can just give you the model. You can run it on-prem. Or we can host them, of course, for you in the cloud and AKS servers, or we can help you deploy them on edge devices. So cognitive services, very quickly. Cognitive services are pre-trained models in the cloud and on the edge. Because some of these models you can actually get in a container and run on your edge device. Some of them run perfectly fine on a Raspberry Pi. So we have vision, speed, language, and knowledge. There are around 50 APIs at the moment. So you have vision to make your application see, speech to make your application listen and talk to you, language to understand what is being spoken, and knowledge if you want to tap into the knowledge provided by our Bing APIs. But today we're going to level up a little bit, and we're going to create our model from scratch. So for that, we can use Azure Machine Learning. It says Studio. It goes by many different names. So we have Azure Machine Learning is the correct name, but it also goes by the name Azure Machine Learning Studio with a small s, because with a capital S, it is a completely different product. So remember, Azure Machine Learning is the right name. And this is a service combined of services that helps you to build, deploy, and share your model. So it facilitates the complete life cycle of a model, and you can actually monitor them in production, which is quite cool. So today we're going to answer the question, is it a llama or probably a cat? And for that we need the Henk's llama and cat dataset. So I scraped the internet with Bing and got a lot of cats and a lot of llamas mixed with alpacas. We got around 300 images of both classes. So what are we going to use? We're going to use Azure Machine Learning. We're going to use PyTorch. We're going to use a bunch of GPUs. And then we're going to use something to deploy and run our model in the cloud. So how does a workflow typically looks if you want to work together as a team on creating this llama cat model? So first, let's have a look from the data science perspective. Our data scientist has to create, shape the model, program how the model is going to train, what framework we're going to use. So the data scientist probably wants to use his or her own tools, and it's probably Jupyter. Of course, we're going to make sure everything is in version control, and then we're going to use Azure Machine Learning Service, Studio, Azure Machine Learning, to create the model. And we're going to register that model in a service called Model Management. And you can see Model Management as like the NuGet repository for models. So the data scientist can check in the model. Hey, here's the model. It's version 3. This is the name. And then our developer can pick out the model from model management and build software around it, because a model without code around it doesn't do anything. It's just a file that you have. And you have to load the file and write a function around it. And that also has to perform, because you probably want to expose that model as an API. So a developer has to write software around it and want to use some other cool tools for that. Maybe he wants to write C#. Maybe she wants to write Python, Java, whatever. So you can use their favorite tools. Of course, we're going to use version control, set up a nice build pipeline, because that is what you do, and this will end up in an Azure Container Registry. And then, because it is in an Azure Container Registry, our operations team can just pick up the model and deploy it like it would, not the model, the container, can pick up the container and deploy that container like the team would deploy any container, because from now it is just a container. And then you can send Simpson images to it, and then it will probably say, yeah, it's a llama, I guess. And then, but you can send your images to that model running in an Azure Community service. So what is Azure Machine Learning anyway? It is not just one thing. It is a set of Azure Cloud Services, which you can control with the Python SDK, with Azure CLI package, or just an API. And it enables us to prepare data, build models, train models, manage those models, like the model management I was talking about, and track experiments, and deploy those models in production. So what are we going to do? We're going to go through 3 stages. First, we're going to prepare our environment, set everything up so we can work together as a team. Then we're going to experiment with our model and data, and then we're going to, when our model is ready, deploy our model in production. And probably this is going to be ending up in dev test. So first, preparing our environment. We can do that in many different ways. We can go to the Azure portal and we can click, and our Azure Machine Learning environment is there. We can do it from Visual Studio Code using our AI tools for Visual Studio Code, or we can do it with our Python SDK. And I'm always for not clicking in the portal, but having it in some way that someone else can actually redo it. So using the Python SDK, you can just code that the environment is being created, which is pretty awesome, and checking your code so everyone can actually do it. Recreate it. So creating a workspace. From now, I'm just going to show Python code how to do things. Creating a workspace. You say workspace create, give the name, point to your subscription ID, your resource group, and the location you want to have it in. And this is already a very important choice, your location, because later on we're going to use virtual machines, AI clusters, to train our models. And they consist of virtual machines. And you'll likely want to have some virtual machines that actually have some GPUs, because then your training goes way faster. So first, before you create this workspace, check if those virtual machines are available in your region. So the main region, West Europe, I think East US, you're pretty sure that all the machines are available there, but in the smaller regions or newer regions, it might not be the case. So you want to have NC, NVIDIA compute machines available if you want to do something with machine learning. So you create this workspace, and then you can write out a configuration file. You check in that configuration file, and everyone else can connect to that same workspace with workspace from config. And of course, underneath, you have to connect and authenticate to your Azure environment like you normally would do. And this is what you get, ml.azure.com. So it doesn't live inside the Azure portal. Of course, it is all there in the Azure portal, but to use it, you go to this website, ml.azure.com, and you get a few cool things. Let's zoom in. So first of all, we have data sets. Here we register our training data. In our case, we're going to create a data set with llamas and cats, and we're going to upload it to data sets. We're going to create a data set from that data. Then there is experiments. These keep track of all our training runs. So every time we try to train a model, it's called an iteration, we're going to see all the log files and everything back under experiments. Then when we're happy and our model is there, we can register it. And the models, that is the model management I was talking about earlier on. Then there are endpoints, two types of endpoints. There are real-time endpoints. Here we can find our deployed models. And then there are pipeline endpoints. We're not going to talk about creating complete training workflows, but if you want to do that, if you want to create a workflow, then you can publish that workflow and everyone can call a REST API point to actually kick off that training workflow. Then we have compute. Here we can manage all our different types of compute, our notebook compute, our training compute, our actually inference compute. It is all there. You can all manage and create it from there. Then there are data stores. And here you manage the connections where your data actually is. So we are going to upload images, and those are on a blob storage, a blob in a blob store, blob container. So under data stores, we can manage those connections to those blob to those storage accounts or your SQL server. So that in code, we just have to reference a data store instead of using credentials in our code. And that's pretty handy. So now we have our workspace. Step one. In that workspace, now we need to create compute so we can actually train our models. So to do that, you need two lines of code. You say Azure Machine Learning Compute, provision for me this cluster consisting of standard NC6 machines. And this is the cheapest virtual machine that actually has a GPU. They're around 600 euros a month if you have the promo version. So you want to shut them down if you're not using them. So this configuration you see on the screen now, make sure that there is always one node up and running, minimum nodes 1. So that will bill my credit card constantly. If you put it to 0, it will automatically boot up your cluster if there is a new job. So you have to add like 5 minutes to your training. So I never do that in a demo because we don't want to wait for these machines to actually start up. But I highly recommend you doing that if you're going to play around with it, because these things are pretty expensive. Max nodes you can set to 6 or 8 or 10 or whatever you want. And that means if you have multiple jobs, it will just spin up a new machine next to it. Spin up a new machine, spin up a new machine, spin up a new machine. So be wise when you create these clusters. And when you have compute, you need a place to actually have your data. You can use the default data store. Out of the box, Azure Machine Learning will create a blob container for you where you can put your data, or you can connect to any other blob container in Azure. It doesn't even necessarily have to be in your subscription because you have to give it your account name and account key in your Azure subscription. It can be everywhere. And then we're going to have a demo and see how it actually looks. And here we are. Let's first have a look at the studio. So this is my studio. Here, yeah, this should be visible. So here we have our home screen where we have our tutorials here. We can play with the designer. We have automated machine learning. We have notebooks. Here we have our previous runs, so you can actually go back and see what has happened. But I want to show you first the tab Compute. So we have 4 different types of compute. So we have compute instances. If you want to use notebooks hosted in Azure Machine Learning, you can create a compute instance. And then you have your you have Jupyter notebooks in the cloud. Here we have the compute clusters. And here we see my cluster. My cluster is called Optimus Prime. And it consists of standard NC6 machines. See, there is one doing nothing, or not doing nothing. It is actually billing my credit card over and over and over every minute. But we see here that it is a standard NC6 NVIDIA compute with 6 cores, 56 gigabytes of RAM, and some storage. And this is the thing it is all about. It has NVIDIA Tesla K80. It is dedicated. It will automatically shut down within 120 seconds. You can also put these machines in your own virtual networks. So now they're just there, but you can also run them in your own virtual network and subnet. It's deployed in West Europe, and that is basically it. And here we actually see and can connect to these compute instances. Okay, so we have compute. And here we have our data store. We here have our workspace, our default blob. It's just here, tells you where it is. You can update your authentication if you have to recycle your keys. So we'll dive a little bit later in and what else is there. But let's switch to our notebook and actually start using the service. So I start with importing a lot of dependencies because that is what I normally do. I always put them up in the first cell. So we will run, and it will tell us our HTML core version when it is done. So I'm running these Jupyter notebooks on my local machine because that is still possible. You don't have to run them in Azure Machine Learning. You can just have them on your own machine or on your own, wherever you want. On your own virtual machines or your own local machines. They can all connect and use Azure Machine Learning in the cloud. So I'm running locally 1.16. I think there is a little bit more updated version available. And then I will connect to my environment. So I say workspace from config. You can see what is actually in the config file. Where is my config file? Oh, not seeing it here. Refresh it. Outputs. Is it here? No. It's hiding it for me. I will find the config file back a little bit later, but it basically says just a connection string, a path to where Azure Machine Learning is deployed. So we connect to our workspace from configuration file. We connect to our compute target, Optimus Prime. So now it is in this variable. We connect to our default data store, and we connect to our first experiment, llamas vs cats. This is how you write llama in Dutch. And we're going to use PyTorch.
Yay, llamas.
Yay, almost, almost. So we run that, we see, and it is connected. So now we get to the data part. So I've run the script to actually get all the images, and those images are in a folder, data, llama vs cats, and I've uploaded them already to our default data store. So the only thing I did was uploading this directory. Data, llama vs cats. So we have a test directory with our testing images. Terrain, we have cats, a lot of cats, and llamas. And we have a validation set with different cats and different llamas. And these are around 25 images to actually validate our model. So what we do is we create a data set from this. So the data is on the blob storage, and then we specify, hey, from this part of the data, we're going to create a data set, and we register the data set as llama vs cat, a data set with llamas, alpacas, and cats. So we can actually see that data set here under data sets. You can click on that. You can see here how to consume this data set, and we can explore it a little bit. So it will index it, and then later on, it will figure it out eventually. Yeah. Index the data set, and here it is going to load some previews from the data. Can do it, cat. It's a cat. And then you can browse a little bit the data. It's not the best to preview your data set. So you can do that. So you only have to do that once. So later on, you can just connect to the data set by saying dataset get by name llama vs cat. And then we can preview it. So we will run the script and we will actually preview it. Here we see some, I guess these are alpacas and these are kittens. It's even a camel, I guess. You're the expert, Lars.
Oh, you're putting me on the spot now.
Yeah. What is that? It's a camel.
No,
right?
that's not a camel. No,
Oh.
I don't think it's a camel. It looks like a llama, to be honest.
With a nice haircut.
Absolutely.
Cool. So we can walk through the data set here, and we see some fun images. So this is our data set. This is the data we're going to feed our model. So now we have the things we need to get started. We have our workspace where we can work together. We have our compute, and we have our storage, and we have our data set. So now it is time to actually start building our model with the data we have. And to do that, we need to create an experiment or connect to an existing experiment already. And this is the glue that holds everything together. All our log files, everything is versioned under that experiment. So we can dive into that later and see, okay, the mistake was there, or we changed this line of code to create this model. We need an Excel file that is training the model for us. This is mainly what your data scientist will give you. Or you get an example like me from the PyTorch website and you run it. So this can be anything. This can be, as long as there's a Python or an R file, it will actually run. So we are going for a PyTorch file. Then we need to specify the environment where this training file is going to run in. So you can do that in two ways. You can pick out a curated environment. So these are the environments the Azure Machine Learning Service team maintains for you. So you say, give me an Azure Machine Learning PyTorch for a GPU optimized image. Or you can create a custom environment by giving it a name and telling which pip packages and which conda packages, or one of the two, you want to have installed. So the curated environment is easier, obviously, because you'll just pick it out and spin up this Docker container, deploy a script to it, and run it on your cluster. So the custom environment is a little bit more safe because it is your environment. Nobody is updating it except you. So yeah, you may make your choice for this. I'm going for the curated environment. So when you have your environment, you have to specify how your script is going to run in that environment. So I will first have to tell it where it can pick my data from. So I have to tell it the data folder is that data set and mount it as a virtual directory in my Docker container. It's just done by one line, specifying data file. Then I can pass some additional parameters, like how many times I want to have my training script run over the data, and you can specify as much incoming parameters as you want. You have to tell it where it can actually find your training script, and then which training script it actually has to run. So basically I'm saying here, download everything from the training scripts folder to the Docker container, to my curated environment. And when you're done with that, just execute train.py. And then it will start running that thing. And do that on that compute target. And this is my environment. And these are my incoming arguments. Then you can submit that experiment, that configuration to Azure Machine Learning, and that it will deploy it on that cluster for you. And it will start running and training your model and eventually delivering your model. So let's actually do that. Let's actually do that. Yeah, here we go. So this is a training script. I got this training script from the PyTorch website. It was a basic example on how to do transfer learning, so you don't have to train your model from scratch, but can use, in our case, ResNet 18. It's a pre-trained model. So the only thing what I changed is I added a few things to this script. I added some references to Azure Machine Learning. I connected to the current run context, so it can actually communicate to Azure Machine Learning. To Azure Machine Learning. Then the model goes in. The script works like this: it parses the incoming parameters, transforms the data. That every image has the same shape, because the script doesn't really like it, or it doesn't work if one image is big and one image is small. They all have to be exactly the same size, because this model basically goes back to all the pixel information and picks out the values of the colors of every pixel. So it just creates a big array of data from it, a big array of numbers. Then we actually come in the training script, and this is going to run a few times. And in those training rounds, I've added some logging. I say run log the current accuracy of my model. And because I log it every time under the same name, Azure Machine Learning Service will understand that it has to draw a graph from this data. So when I actually hit and run this training script, we will see a graph coming, and we will see the accuracy improve or, of course, fall down if I'm doing something wrong. And then one final thing, your script delivers a model, a file. In this case, model.pytorch. And I said this deploys something on a cluster that will shut down in a Docker container. So you need to do something to get your data out of it. So everything you save in the outputs folder will automatically be copied back to your Azure Machine Learning environment. And you have to write. So everything you set in your outputs folder will be copied back. So we have our model and we have our labels. So let's run that. Let's run it here. So we have now our training script in the directory training scripts. We're going to create now a new run. So we connect and get our curated environment, our PyTorch 1.6 GPU. And here we're going to specify how it has to run. So we connect to our llama and cat dataset as a named input llama vs cats, and we mount it. Our training scripts are here. So we tell it everything in the project folder, execute train.py, run on this compute target, use this environment as we specified, and use this incoming argument. So we can change this to 10 or 12 or 15, doesn't really matter. And then we run it, and then we wait. So we will wait a little bit and see if it is actually going to run. because that's what we want to see. So now we actually see the Docker containers pulled out, the scripts are being copied, the Docker container is going to be deployed on that AI cluster. And then it will start executing our training scripts, which we've done up there. Start executing this script. Starting the Docker container. And the cool thing is we can actually follow everything here and we can switch log files here later on. Starting, it automatically switches files for you. So the most interesting thing happens in this log file. So here we see it is already starting with his first training round. So it mounted already the data store up. Preparing to call the script train.py with these arguments. Here, llama get, number of training rounds. It's downloading the ResNet model, and now it is running, going in that for loop, training our model. So here we see the graphs. So it is now in round 2. It's doing another round, and then we will see that it is changing and drawing these graphs for us. So this it will do now 12 times. So in the meantime, we can go back and look at this picture to see what is actually happening, because there are a lot of steps that are done automatically for us. So from our Jupyter notebook, when we hit submit, it snapshotted the folder with all our scripts in it and send it to our experiment. It's created a Docker image based on our environment specification. It deployed that Docker container to our compute target, mounted our data stores in that container, and launched our training script. And while that script is running, it streamed back all the logging to our experiment. And because we are running that widget that actually can visualize what is going on, we can actually see that log file and what is going on in our Jupyter notebook. And then when it is done, it will copy over everything in our outputs folder to our experiment. So when everything is copied back, we can register our model in model management. And that is just by saying register this model. The model name is cats vs llamas or llamas vs cats. And then we tell it where it can actually find the model file. In this case, it is just in the output folder. So let's see if our model is actually done. And where are we? We are around 10. I talked too fast. So we'll have to wait a little bit when it is done with the last training round, which is now. You can do it. You can do it. Cool. So
maybe Lars has a fun fact about llamas in the meanwhile, while we wait.
Oh, yeah. That sounds good. Let me take some coffee.
Yes. Well, interesting fact about llamas. Well, there's many, but llamas don't spit. Well, they do spit. But we have guests coming here to our farm, and they're always asked if they spit, and they don't. It's something they do against each other to kind of get off my back kind of thing. But they don't spit at people. It's just something that people think. If you corner it, maybe it'll start kicking you instead, and that's just nasty. So that's one fact for you about llamas. And also in llamas versus alpacas, it's often that you get them confused, which I can understand. They are very similar, but llamas are significantly bigger, much bigger, and they're not as foofy. Alpacas, you get that foofy face where it looks like they've been in a tumble dryer. So that's one of the ways you can tell them apart. But yeah, I had to have llamas in my backyard to figure that one out. I wasn't sure either. We thought they were alpacas at first, but I've learned. So yeah, llama facts for you.
Cool. Yes.
Well, the run is complete. Time well spent. Yeah.
Cool. So our run is complete, and our model is now in versioned at our run. So the best way to see it is to go to that run. So we see here the latest run is number 4. This is my time. We click on it. We go to outputs. Go to the output folder, and here we see the model file and we see the label file, cat llama, number 1, number 2. Here we see our log files, so we can actually go through and see what all produced. We can see the snapshot it made from our training script, the script we went through. We can, I don't know what images are. Here we can see the metrics. We can see the graphs that was generated. So you can use that log function to log everything you want, and then everything is being here. Which is very handy to compare models, because on your home page, and probably somewhere else, on your experiment, here you can compare the graphs against each other, like how the accuracy performs and so on. So really useful stuff if you know what you're actually looking at. But what we want to do is we want to register our model, because we are really happy with it and it works perfectly. So we want to register and expose it for everyone to use. So I say run, register my model. Look for it in the outputs folder. Everything that is there you can register. Call it llama or cat PyTorch. You can specify a lot of different things so people know what this model is about. So it is a PyTorch model, it's a 1.6 framework, you can have a description, and we can actually tag it. So we will call this one Azure Alive. And then we can specify a preferred resource configuration. So in this case, we want to say, okay, to run this model, you need at least 1 CPU and 2 GB of memory. Otherwise, it is hopeless. So we will run this. And now our llama or cat PyTorch model is registered with version 3. So we go to our model section. And here we see our model. So we can click on that model. And now the cool thing comes. So here we have our tags. But here we can see which experiment has generated this model, which Excel run ID has generated this model. So from now, if someone goes to model management, picks out the model and wants to see which parameters did they use, they can just go and read the log files, see even, because here on the run you can see which data it has used, which version of the data set. So from the model you can go back to how this model was created, which is really useful if you want to debug the model, especially to, for instance, figure out why my model is seeing llamas and alpacas as the same thing. You can trace it back, look at the data, and you see, Henk didn't know the difference between llamas and alpacas. So you can trace that all back. And this also highlights the point, we're going to see it later on, but the model is as good as the data you give it. If I tell my model and train my model and say, this alpaca is a llama, my model will not say, no, Henk, you're wrong. It will just say, yes, you're right, Henk. And it will assume that that is actually a llama and not an alpaca. But now we probably want to see if it is working, I guess, after all this time. So we will download our model from model management, stored in our local outputs directory, and we have to write a script that will actually load in that model. So we load in our model and outputs, model, we load our labels. I had a directory with test images. We actually have to shape them the same way as our model expects our images. So we resize them to 225 pixels and then crop out the center. We convert it to a tensor, and then we run it through the model. Yeah, and we run it through the model, and then we return the result as JSON. And this is just a loop that will actually run through our images. So let's run it and see if our trained model is actually doing any good. Running through the images, running through the model, 1, 2, 3. And here we are. We have 6 cats. Like 99% sure that this is a cat, so that's good. Then we have our alpacas. Still, because I tagged these ones as llamas, it will actually say this is a llama. We have our fluffy fellows here. So my model on my testing set is actually doing what it was supposed to do. So now we can move on to how we can actually deploy and expose our model so everyone can use it. And for that, we need to create a few things. So we can let Azure Machine Learning handle it from here. But because it is model management, you can also pick the model out and do whatever you want with this model. So you don't necessarily have to do this, but this is a very easy way to, and I think a good way, to deploy and run your model in an environment. So to run it, you need 3 things. You need, of course, the model. You need a file that can run the model. And you need to specify how the environment is going to look like, where the script and your model can actually run in. These 3 you wrap up and you create a Docker image. And that Docker image Docker container you can deploy wherever you want. The scoring file is quite basic. You can make it as complicated as you want, but what it is going to do, it has 2 methods, and those ones you really need. So the first one is to load your model. Loading in a model takes time. You don't want to do that on every incoming request. So you load in your model, and then on every incoming request, you shape the data, and you run a prediction against your loaded model and return the output. Environment file, exactly the same as what we did when we were training the model. You can have a curated environment or create your own environment. You combine those things you have configured in an inference config. So you say the runtime is Python. This is my scoring file. This is my environment file. And then you can deploy that inference config, the deployment config, to an Azure Container Instance or to a linked Azure Kubernetes service. Deploying in ACI, you can do that in code. Of course, you can also do it from DevOps and other ways, but in code it is very easy if you want to test something. So you say Azure Container Instance Web Service, deploy this configuration, 1 CPU, 2 gigabytes of memory, and deploy this model. This is the inference config, this is the deployment config, this is the model. And this is the name. So AKS, the only extra thing you have to do is to point to the AKS compute that is linked by just giving it a name. So let's deploy it. I think let's do an AKS service because I think we will have. Yeah, we can manage that. So deploying the model, creating the scoring script, load in the model. Run, shape the image, run it through the model, return the prediction. The environment. We are creating a very dedicated Llama vs Cat inference environment. We use the Conda Package Manager to install Azure ML defaults, PyTorch, PyTorch Vision, and Pillow. And we add that to our environment. These dependencies. That's it, what you need to do to create the environment. Then we create an inference config pointing to that environment. We specify it here and tell it to run this scoring script. So we can deploy it to an Azure Container Instance, but I don't want to do that. Let's go for the Azure Kubernetes service. So we connect to my AKS compute Azure Kubernetes cluster called Exodus. We say we need to have this AKA web service deploy configuration is use 1 CPU core and 2 gigabytes of memory. We can also extract those values from the model. That is what we done here. So we can also say model resource configuration is this. We first have to load in the latest version of the model, because otherwise it is not going to deploy our model. Here's version 3 of our model. We call it a Llama Arcade PyTorch. We will call it Azure Live. Specify which model, so you can also specify multiple models here. We specify the inference config, the deployment config, and the target, and we say override is true, so we can be deployed under the same name. So let's do that. Inference config is not specified. Yeah, you have to run that, Henk. The thing I'm doing is Shift Enter. So you can also click run, but you have to run all the cells, otherwise it doesn't work. Like we saw here. So now we follow it real time, and if my Kubernetes cluster still has space, then it should be able to deploy very fast. Because deploying it to an Azure Kubernetes service, which I cannot spell apparently. Scroll away, Henk. Deploying it to a Kubernetes service is faster than creating a new Azure container instance. Succeeded. So now our model is deployed in our AKS service. We can connect to the service. We will get a scoring URL, and by default, if you deploy to an AKS service, it is secured with API keys. So that's pretty cool. ACI by default not, you have to enable that, and it is automatically load balanced. I will show you later how it looks like, but I think we first want to see if it is actually running now on this URL. So here I have a bunch of testing images, actually the same as we used before, and here I have a small script that will connect to our AKS service. It goes to the list of images and sends them to the AKS point here. Run it. Sending all these images. So what it does is just posting this JSON to the endpoint for you. It's a nice helper method. And here we see it is giving us exactly the same data. It's 99.9% sure that this is a cat. Here are the rest of our alpacas. So that is working. So now what we can do is we were in our model number 3. Now we can actually see where it is deployed. And here we see it is in our deployment Llama Arcade Azure Live on our compute target Exodus. It's an AKS. So we can click on that. We can even see which Git repository is there behind, which Git commit I have deployed. When it is created, which model is there, the endpoint, the configuration, Swagger URL is there, number of replicas, when it is going to scale. You can actually test it from here. I haven't seen that. Test is not supported. Yeah, can imagine that. Here it will show us how you can actually consume it using a token, using our keys, and recently added the actual deployment log, so you can see if anything goes wrong, which is pretty cool. So what did I do for this to actually run in AKS? I went to compute and I've created an inference cluster. Exodus. So what I've done is I just created a new AKS cluster from here. But you can also use an existing cluster. So if you have already an AKS cluster in your Azure subscription, you connect to it, and then it will start setting up your inference environment for you. And you can deploy all your models in that same environment, and it will handle everything for you, which is pretty handy for me if you don't know that much about AKS. So we have our model running in a container in an AKS service, which can very well detect cats and things that look like llamas. So what have we done? We have done a lot of steps to actually get something from a little bit of data all the way up in a container in an AKS service. So we started with preparing our workspace, setting up the space where we can work together, configured training compute and storage. Then we created an experiment. We trained our model and registered our model and model management. From that model and model management, we've created a deployment and deployed that to an AKS service. So if you want to do this yourself with Simpsons, then you can go to ak.ms/Azure Machine Learning AMLS-PyTorch. So thank you. And that was it for today.
Thanks, Henk. That was a lot of steps. I'm gonna have to go back and see this. Actually, it's interesting because I need this exact approach, because I do have llamas and I do have a llama cam, and I want to be able to, for no apparent reason, give push notifications when there is a llama on the screen. And I think this is exactly the scenario that I'm sort of after. So somehow, I mean, I've spoken to you before about this whole system I want to create, but I need this video stream to basically, every minute or whatever, have a snapshot or a screenshot or whatever, and put it through an ML.
Yeah.
It's kind of process to figure it out. So
this service you can actually
names.
Excuse me?
Do the llamas have names? But you could actually go a step deeper and see which llama is on the stream.
Or we could sponsor them. You want to buy a llama as a sponsorship? But there you go.
Yeah, for your case, it would be really good to use like an IoT Edge deployment, because then you can create your own container running this model, have a camera module that processes all the frames, sends it to the model, and then only sends out, hey, I've seen a llama, out to the internet, because I don't think you want to send all the time all images over your internet connection.
Especially
no, because
yeah.
I don't have Starlink yet, so we're not quite there. No, that's right. It's an interesting proposition of where do you put ML into the chain of everything, right? So it's very cool that we can do all these things with machine learning, and we can figure out what things are and find patterns and all that. But like, where's the real world kind of implementation? That's what I usually try and find when I do these projects, so that I have something real to work with. So it's not very useful, but it's real world.
Yeah.
So
and it's fun. Yeah,
it's fun. Yep, exactly. Now, where do people go if they want to get started? So you have, obviously, you said AKS, MS, AMLS, PyTorch. I'm reading off the screen. Is that the best place? And is there like a free tier or anything that you can get started with?
I would definitely say go to Learn, to Microsoft Learn, and follow some courses about what Azure Machine Learning does, all the different types of services, because if you want to create a simple classification model like this, you can also use, for instance, Azure Custom Vision. Then you just have to upload your images, and it will create this model for you. It will also give it as a container, and it will also run on IoT Edge. But this solution is really good if you need like a very specialized model that just does your thing, and you want to have full control over the whole life cycle. So you could be able to explain what is going on. We didn't even dive in that part yet. But definitely visit Microsoft Learn and do a course on this. If you are a little bit advanced and using a similar tool, then I would recommend going and downloading the notebook I've made, because that will just show you how to do it. If you like code examples.
Yeah, exactly. And then press some buttons and see what happens.
Yeah. And to answer your question, you will pay for your compute.
Yep. But as you said, remember to turn it off when you're done.
Yeah, and you don't need this expensive GPU machine, you can also use. I also had a cluster called Bumblebee, and that consisted of cheaper CPU-enabled machines. It just takes a little bit longer, but it also, if you're not in a hurry, like during this presentation, we don't want to wait 30 minutes for the model to finish, but you can also go and get coffee and come back.
Oh yeah, exactly. Yeah, if you're sitting there, you're just trying to make it work. You're not presenting it. That makes sense. Yeah. Oh, very good. I don't have any other questions. I don't know about you.
The sound stopped working, Lars.
Oh, no one hears me.
Hear him. Can you hear him, Henk?
I can hear Lars very well.
Okay, then it's just my Okay.
Yeah, I wouldn't be surprised. All right. So I think that's all we got. So thanks everybody for watching. Even if it wasn't live, you might be watching the repeat because it's on YouTube. And if you've got any questions, ask Henk, not me.
Absolutely.
Yeah, so with that, let's wrap up. Thanks again for being here, Henk. And well, hopefully all of you will see you next time on the next show, maybe with Lars, me, or Esteban, one of our hosts, or multiple, depending on the time where we host it in. So yeah, right. Great to have you, Henk. Learn a lot of stuff about llamas and machine learning. So that's
always good.
Okay.
Yeah.